China's growing arsenal of long-range anti-ship ballistic missiles is reshaping how the U.S. Navy prepares for a potential conflict in the Western Pacific. Systems such as the DF-21D and DF-26 are designed to threaten U.S. aircraft carriers operating near Taiwan, the South China Sea, or the Chinese mainland. Supported by satellites, over-the-horizon radars, airborne surveillance aircraft, and reconnaissance networks, these missiles form a key part of China's anti-access and area denial strategy, aimed at pushing American carrier strike groups farther away from contested areas. This creates a major operational challenge for U.S. naval aviation. If aircraft carriers must remain hundreds of nautical miles farther from combat zones in a high-intensity conflict, especially around Taiwan, it could weaken the Navy's ability to maintain persistent surveillance, air defense, and strike operations. The Boeing MQ-25A Stingray is designed to address this problem. As an unmanned carrier-based aerial refueling aircraft, it will extend the reach of U.S. Navy carrier air wings, while allowing aircraft carriers to operate at safer standoff distances. According to the Congressional Research Service, the Navy wants the MQ-25A to deliver between 14,000 and 16,000 pounds of fuel at a distance of 500 nautical miles from the carrier. In practical terms, this means carrier-based fighters can fly deeper into contested airspace, while the carrier itself remains farther from Chinese missile engagement zones. The MQ-25A is more than a support aircraft. It is expected to become the U.S. Department of Defense's first operational unmanned tanker, and the U.S. Navy's first carrier-based unmanned aircraft fully integrated into fleet operations. Navy officials have described it as a pathfinder for the future carrier air wing, where unmanned systems, artificial intelligence, and human-machine teaming will play an increasing role. One of its most immediate benefits will be to free F/A-18E/F Super Hornets from their current role as buddy tankers. By taking over the tanker mission, the MQ-25A allows more Super Hornets to return to strike, fleet defense, suppression of enemy air defenses, and air superiority roles. This change improves both efficiency and combat power. Every fighter released from tanker duty becomes another aircraft available for operations. Carrier aircraft supported by MQ-25A tankers can remain airborne longer, patrol larger maritime areas, escort strike packages over greater distances, and conduct extended surveillance missions across the Pacific, where distances are a central operational problem. The Stingray also strengthens aircraft carrier survivability. By extending the combat reach of carrier aviation, it helps U.S. carriers remain outside the most dangerous zones while still projecting power into contested areas. This directly supports the Navy's distributed maritime operations concept, which seeks to preserve combat effectiveness despite long-range missile threats, electronic warfare, cyber attacks, and communications disruption. The program's origins go back more than 2 decades. The U.S. Navy and DARPA began exploring carrier-based unmanned combat aviation in 1999, leading eventually to the UCLASS program. In 2016, the Navy shifted its focus from a stealth strike drone to an unmanned refueling aircraft, creating the Carrier-Based Aerial Refueling System, later known as the MQ-25 Stingray. Boeing was selected in 2018 to develop the aircraft, and its T-1 demonstrator first flew in 2019 before completing its first aerial refueling mission in 2021. Production is centered at Boeing's facility at Mid-America St. Louis Airport in Illinois, where a new production site opened in 2024. The aircraft uses the Rolls-Royce AE3007N turbofan engine, while BAE Systems provides key vehicle management systems. The MQ-25A is also expected to use the Cobham Aerial Refueling Store already employed by tanker-configured Super Hornets. At the same time, the Navy is building the command architecture needed for unmanned carrier aviation. This includes mission control consoles, communication systems, networking infrastructure, and software to manage unmanned flight operations. The first carrier-based mission control system was installed aboard USS George H.W. Bush in 2024, marking an important step toward operational integration. The program remains under close congressional oversight because of its cost, delays, and strategic importance. For fiscal year 2026, the Navy requested about $1.04 billion for MQ-25 related procurement, development, testing, and evaluation. The current program of record covers 76 aircraft, including 67 operational aircraft and 9 test and development aircraft. Initial operational capability, once planned earlier, is now expected by the end of fiscal year 2027. Oversight bodies have also raised concerns about beginning low-rate production before enough testing is completed with production representative aircraft. Even so, the strategic logic remains clear. The MQ-25A does not eliminate China's missile threat, but it gives U.S. commanders greater flexibility. It extends range, distributes fuel more efficiently, reduces pressure on manned fighters, and helps carriers remain relevant in an era of long-range precision weapons. Its future role could also expand beyond refueling. Lawmakers and defense planners are already considering whether future variants could support intelligence gathering, electronic warfare, communications relay, attack missions, or even land-based tanker roles. The experience gained from integrating MQ-25A into carrier operations could open the way for a new generation of unmanned naval aircraft. In the Indo-Pacific, where distance, survivability, and persistence may determine the outcome of future operations, the MQ-25A Stingray could become a decisive enabler. Its value is not only in the fuel it carries, but in the distance it creates, the combat aircraft it frees, and the operational flexibility it restores to U.S. Navy carrier strike groups facing China's expanding missile threat.